values, it is negative 2, 2, 2, and 0. ها تمام شباب؟ Okay? Okay. Okay, it's done. I read the first of them. Now I need to write Taylor expansion. Okay, he wants you to write Taylor expansion of G and of the second order. In order to write Taylor expansion, it's gonna be the value of the function, as we know from yesterday. This is the value of the function. Then I will get the first derivative, the differential of the first derivative, then the differential of the second derivative. Once more, because you said memorize the main equation. So the main equation, yes, you're right, it's gonna be like this. This is gonna be the approximation of x and y. So it's gonna be f at 0 and 0. Then I will have the differential. The differential is gonna be partial f partial x times x minus the point, which is 0, plus partial f partial y times y minus 0. This is the first derivative. Then I will write the second derivative. Okay? The second derivative will be, okay, once more, it will be the differential of second part divided by on the factorial of 2. How to write the differential, Mr. Yusuf? This is gonna be partial 2f partial x squared, partial 2f partial x partial y, partial 2f partial y squared. This part is gonna be is gonna multiply by x minus 0 to the power of 2. But since it is 0, I will multiply by x squared. Then 2 of an x minus 0 times y minus 0. So I will multiply in xy. And then this is the last one, which is y minus 0 to the power of 2, which is y squared. That's the second component. Of course, as you can see, that Taylor, in general, or what's called the Maclaurin expansion at 0, it's f0 plus f dash at 0 plus f double dash at 0 on factorial 2 plus f triple at 0 over factorial blah 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 plus the remainder term. This is for single valued functions, but this is not a single valued function. This is a function in several variables. So the first component, which is f dash, it is the differential. The second component, which is f double dash, it is the differential, okay, of the main function, as you can see. Now, after writing all of this, I will add the remainder term. The remainder term simply will be limit x tends to 0 divided by the x and y to the power of 2. And of course, this is Rm, which is going to equal to 0, as you can see. That's the expansion of Taylor, as I told you. So once more, if I start using the substitutions, Mr. Karim, this is the law. Remark that all of these values, you already have them. Because he gave you, at the beginning, let's go through the problem. He gave you the value of the function g, which is 2 minus x squared e to the power of xy. So if I substitute it at 0 and 0, this is going to be 0, that's going to be 1, and this is 2. So the value of the function is equal to a g, 0 and 0 is equal to 2. Okay, I will go to the differential. The differential, you can have the values from the gradient vector. And the first component is equal to 0, the second component is equal to 0. This is why partial g, partial x, partial g, partial y is equal to 0. So all of this part is going to remain just only 2. Karim, go to the Hessian. This is why he gave you the Hessian matrix at the beginning. Now, if you look, partial 2g partial x squared from the Hessian matrix is negative 2. Partial 2g partial x partial y, which is positive 2. Partial 2g partial y squared is equal to 0. You are set. Now I can find the expansion, as you can see. Also, it's a very good problem handling the part of Taylor and connecting the partial derivatives with the main law and everything. It's supposed to be really a very simple problem. But as I told you, a simple problem that you will have to solve more than once. Okay? Look to this magnificent problem. He gives you A, B, C, and D, and double Y, which really tests everything that we did go through in the previous session. He wants you to consider the function h, which is almost h u and v of class C infinity homogeneous of degree 3. What's the meaning? So he's giving you an information about the homogeneity. Okay, and it's of order 3. Consider also the function f. So he defined function h and he gave you function f. With f, you have a part explicit, which is x cubed y cubed, معايا Mr. Yusuf, plus the h function that I announced for you earlier, which is this part is of homogeneous 3, okay? And they continue. And he wants you, number A, to determine partial f, partial y. How to do partial f, partial y, Mr. Karim? I will start differentiating this function. So the first part will have no problems. It will be 3y squared times x cubed. Then I will start to differentiate this guy. Once you get to this guy, once more, we already did this plenty of times. I will consider this part to be u and that part to be v. And I will use the chain rule once more. So here we go. Okay, this is x cubed y cubed, this is the main function, this is u, that's v. I will start differentiating with respect to y. So it's going to be 3x cubed y squared, that's the first component. Then I will start differentiating partial h, partial u, partial x, plus, we are differentiating with respect to y, I'm sorry. Partial h, partial u times partial u, partial y. Here we go. Plus partial h, partial v times partial v, partial y, as you can see. All I have to do is to substitute. Okay, the second step, this is gonna be exactly the same. This is partial h, partial u, I will see it down the road. But partial u, partial y, it will come from this part. This is gonna be 0, this is gonna differentiate with respect to y, it will leave you with an x. Then partial h, partial v remain the same. Partial v, partial y, similar manner, it will leave you with 4y. So that's the first request, and it's very, very simple. Okay, done. So that's the function. Also, you said remark. This is h, but h is a function in u and v. So this is why I wrote u and v, because if I use the numbers as we did previously, now I know which number that I'm going to use. Okay, once more, I will try to get partial 2f, partial x, partial y. That's the first derivative with respect to y. So I will need to differentiate with respect to x. So start differentiating with respect to x. The first one of them, which is gonna be 3x cubed y squared, it will have no problem. It will be 9x to the power of 2y squared. Then I will come to this part, differentiating x once times this value and so on. So I will start according to the derivative rules. This is gonna be 1, this is 1 times partial h, partial u. Then x will stand, I will differentiate this function. So it's gonna be partial 2h, partial u, partial x, plus partial 2h, partial v times partial v, partial x. If it is exist, as you can see, partial v, partial x is equal to 0. This is why the second component, I didn't write it. Same way like for the other part, which is 4 and u, partial 2h, partial u, partial v times partial u, partial x, the remaining, it was not written because partial 2h, partial v, or partial h, partial v is equal to 0. So all I have to do now is to just simplify my stuff as much as possible. And this is the case of my function. This is the explicit for writing h is a function in what and so on. I have the first derivative, the second derivative. Okay, now I'm going to move to step number 3. I want to show if it is homogeneous or not. Okay, once more, In order to show if it is homogeneous or not, all I have to do is to get the value of f of tx and t of y. So I will replace every x and y by tx, ty. So it's gonna be t to the power of 6, I believe, x cubed, y cubed, then plus h of t squared x and y minus t squared x squared, and then to t squared y squared. Take t squared as a common from the argument, it will go outside h by t squared to the power of 3, which means it's a homogeneous function. This can be written as t to the power of 6 times f of x and y, so it's a homogeneous of degree 6. طبعا I've had an advantage of knowing that the homogeneity of h is equal to 3. This is very, very simple, but as I told you, it's important to understand it, how it goes here. So once more, making the substitution, as I told you, this, what is C? It is C. This is partial f, partial y, this is partial 2, partial x, partial y, the results that I have in the first requirement, in A and B, I'm sorry. In C, I've replaced f, x, and y by x times t, y times t, and take t as a common, so it's a homogeneous of degree, as I told you, of degree 6. 3 times 2, it's gonna be 6. So once more, f is a homogeneous function of degree 6, as you can see. معايا يا شباب؟ Okay. Go to the second requirement, knowing that the gradient vector is -1 and -3. So once more, he wants you to understand that the gradient vector, okay, of the input of the h function, the input of the h function are u and v. Once more, who's u, who's v? This is u, صح? And that's v. And for u, it is equal to 0. And for v, it's equal to 8. These are the values, صح? So 0 stands for xy minus x squared. 8 stands for 2y squared. And once you get the derivative of these functions, which means partial u, partial x, it will be -1. Partial u, partial v, it will be -3, as you can see. So that's the explanation of the gradient vector given. So once more, I will start. This is partial h, 0 and 8, -1 and -3. If at 2 and 2, it's simple to get. All I have to do is to make the substitution, replacing the x and y, and then replacing the x and y in here. So it's gonna be 2 times 2, which is 4, minus 4 is gonna equal to 0, then 2 times 2 to the power of 2, which is gonna be 8. So f at 2 and 2, it's 64, plus h at 0 and 8. H at 0 and 8, review your problem, okay, which is gonna come up to 64 plus h at 0 and 8. H at 0 and 8, this will be evaluating using Euler, as I told you. Since f is differentiable and homogeneous, I don't have any information about h at 0 and 8, but I still have Euler. Do you remember, Karim, Euler, what does it say? Euler said that if I differentiated, this is a function which is homogeneous. In my case, is h. So h times the homogeneity degree, which is 3, will equal to the derivatives of g, of h, the function that is given, with respect to x1, with respect to u, with respect to v, times u and v. So now applying this will be u times partial h, partial u, plus v times partial v, partial h, partial v, equal to alpha, which is the homogeneity degree of h, times h at u and v. I know that h at u and v is 0 and 8. So all I have to do at the point 0 and 8, I will start substituting. This u is equal to 0, this v is equal to 8. partial h, partial u from the given gradient vector is -1. And this guy from the given gradient vector is -3. So now I can find the value of h0 and 8, which is -8. Now I can find the value of f2 and 2, which is 64 plus h0 and 8. See how it is arranged all together. So it's going to be 64 minus 8, which is 56. Okay, he wants you to determine polynomial of order 1. Polynomial of order 1, okay? Of the function h1v at 0 and 8. And use it to compute the approximate value of blah, blah, blah. So I need to approximate using Taylor. So what's the equation of Taylor once more? It is the value of f at 0 and 8 plus the differential of first order. Partial the function, partial x, okay, partial u, I'm sorry, partial u, partial x plus time the derivative of the function. I'll write it to you out in just a minute. This is going to be the value of the function, then partial h, partial u times partial u times u, I'm sorry, then partial h, partial v times v once more, plus r1. If you remark, this is of the first order. That's the differential of the first order. We didn't write the differential of second order. All of this you have that. The derivatives already exist from the gradient vector. The value of the function we already evaluated soon. Okay, so all I have to do is to just make a substitution with these values, and then you will have your value of your function. So that's the approximating function. -8 minus u minus 3 v minus e. So if you want to evaluate approximately 0.1, 7.9, all I have to do is to consider u, or the first component, 0.1, and the second component will be 7.9, and substitute, you will have your value, okay? Those problems are, mainly I want you to try them by yourself. It's really very simple. I want you to find or to indicate the degree of the homogeneity of more than one problem in all of these problems. You have the rest, and usually given the practice in the main book, in the main PDF file, which is about 95 pages, like this. You will find the content, then you will have your practice. This is part of it. This is the second part that handles the remaining part of evaluating the Taylor expansion and the constants and everything. I think that's the end of our chapter today, which is chapter 3. I will see in next, inshallah, next Sunday and next Monday, probably we will go to the next part. If it is not, if they didn't reach it in Lisbon, I will stop till the exam. If not, I will continue, okay? Thank you very much. I will see you, inshallah, next time. It's supposed to be till the end of the year. Yeah. For the time being, of course. Yeah. Thank you very much.